Hey everyone. So we're looking at 8.3 today, zero and negative exponents. Real quick though, before we get into this, I'm gonna have you guys try a warm up dealing with the other exponent rules that we've learned, and then we'll get into our new stuff today. So go ahead, copy this warm up and try out these two examples here. Okay, so on number one here, we have this power of 5 on the outside. You guys remember if there's an exponent on the outside of parentheses, that's always where you'll start. So remember that power of 5 gets applied to everything in here, the A, the 2, and the B. All right, so let's go ahead and do it. So a to the power of 7 to the power of 5, power of power always multiplies. So we're getting a to the power of 35. Get down on the bottom, this 2 is getting the power of 5. And this B is also getting the power of 5. All right. When you get to this point here where you get rid of, the parentheses, always take a look and see, okay, is there anything, I can maybe multiply together on the top and the bottom, or are there anything I can cancel out? And on this problem, it doesn't look like there's anything else we can do. So we're done here. Okay. On number 2 here, we have, 1 over 3 to the power of 4 times 3 to the power of 12. First thing is we can multiply this 3 to the power of 12, which is technically in the numerator, by the numerator of this fraction, a 1. Basically, we're just kind of combining these together. So 3 to the power of 12 times 1 gives me 3 to the power of 12. Okay, down on the bottom, we have that 3 to the power of 4. Okay, now we are left with a ratio where we do have stuff we can cancel, right? We have 12 threes up top and we have 4 threes down on the bottom. Try to do this in your head. If we cancel out the threes, we're going to be left with 8 of them up top, right? So we're going to get 3 to the power of 8. All right, so that's just kind of a quick overview of what we learned the last couple lessons. Today, we're getting into exponents that are either zeros or negative numbers. All right, we haven't seen this yet, so I'm going to have you guys go ahead and get this title real quick, and then I'll pull the slide up so you can see all of the rules here. Okay. All right, so here are our, I guess you can think of it as our 3 rules. These are just kind of examples showing you what's going on. So here's the rule, and here's an example of what's actually going on. So go ahead and get these 3 things, and then we'll go through. Okay, so there's basically just 2 types of problems here. There's problems where we have exponents that are zeros, and then we have exponents that are negative numbers. Okay, here's the nice thing. If you ever have anything to the power of 0, your answer is always 1. Okay, doesn't matter if it's a to the power of 0, 5 to the power of 0, a million to the power of 0, your answer is 1. All right, so just remember that. Okay, the big thing here is what do we do with negative exponents? Okay, so here's the first thing to know. We cannot have negative exponents. We can't leave them. We need to get rid of the negative. Okay, how do we do that? Well, it's really simple. If we have a negative exponent that's up in the numerator of a fraction, to turn that thing positive, we have to send that down to the denominator. Okay, and that is what turns it positive. Okay, and that's exactly what's going on here. Okay, if you take a look at our example, this 2 to the power of negative 1, again, it's technically up in the numerator. To turn this thing into a positive 1, we send it down to the denominator and it becomes a positive 1, which, by the way, you might want to put that 1 in your notes just to kind of show yourself, oh, that's why it turned into a positive. It went from the numerator down to the denominator. Okay, and it kind of works the same vice versa. If we have an exponent that's a negative in the denominator of our fraction, to turn it into a positive exponent, we send it up to the numerator, okay, which you can see that's exactly what happened here. A to the power of negative n was sent up to the numerator, and now it's a positive n. Okay, same thing's happening over here. This 6 to the power of negative 2, to get rid of that negative, we send this thing up to the numerator. Again, if you want to show yourself that it's up in the numerator, and now that 2 is a positive. Okay, so it's actually a really simple rule to get rid of negatives. If it's up in the numerator, send it down. If it's down in the denominator, send it up. Okay, cool. So let's go ahead and try it out. Okay, so we're going to try these 4 problems together. Go ahead and copy them, and then we'll try them out. Okay, so I have 3 to the power of negative 2. Cannot have the negative 2. I need to turn it into a positive 2. This is technically up in the numerator of a fraction, right? So I'm going to go ahead and send it down to the denominator, and now it's a positive 2. Okay, up in the numerator, there's nothing there anymore, so we need to show that there's just technically a 1. Okay, next thing is, if you guys remember, if we have a number to the power of 2 or 3, I want us to actually do that math. So let's go one more step here, and let's do 3 squared, 3 times 3, and get a 1 over 9. Okay, taking a look at letter B, we have a negative 7 to the power of 0. It doesn't matter if the number is negative, positive, whatever, anything to the power of 0 is 1. We're done. Okay, on letter C, we have 1 over 4 to the power of negative 3. Cannot have that negative 3 as an exponent. We want it to be a positive 3. So to turn it positive, we're going to send this 4 to the power of negative 3 up to the numerator, and now it is a positive 3. Okay, and really, we can write our answer like this. You guys know, like 4 to the power of 3 implies it's in the numerator, but if you want to show yourself that it's up there by putting it over 1, you can. Okay, but again, let's go one more step. We can actually do this math here. We can do 4 to the power of 3. Make sure you have a calculator. Make sure you know how to type in your exponents. If you don't, ask me, but 4 to the power of 3 is 64. Okay, take a look at letter D. We have a exponent on the outside of the parentheses. It doesn't matter that it's negative. It still needs to be applied to everything in the parentheses, and then we'll worry about it turning into a positive. Okay, so this 1 is going to get a power of negative 2, and this 5 is going to get a power of negative 2. Okay, now that the parentheses are gone, now we can worry about changing these exponents to positives. All right, so this 1 to the power of negative 2 is going to go to the bottom. Now it's a positive 2. This 5 to the power of negative 2 is going to go to the top. Now it's a positive 2. Okay, last thing, we can square these numbers. These are the type I want you to do. So 5 squared is 25, and 1 squared is 1. Okay, and we could leave our answer like that. I would probably go one more step and just write it as a 25. Okay, sorry, I'm kind of out of room there. 25, that looks a little better. Okay, so yeah, really not too tricky. So I'm gonna have you guys go ahead and try 4 of these on your own, and then we'll just kind of move along to some more interesting problems. Give these a try. Okay, so on letter A here, we have 2 over 3 to the power of 0. Okay, here's the thing. We could apply this power of 0 to both of these numbers and get 2 to the power of 0 and then 3 to the power of 0. But here's the thing. Anything to the power of 0, whether it's a fraction, it's positive, it's negative, it's just going to turn into 1. We don't even need to apply it to the parentheses. Okay, so when you have a power of 0, that thing really kind of supersedes all rules, and it turns into a 1. Okay, taking a look at letter B here, we have this negative 8 to the power of negative 2. Okay, we want that thing to be a positive 2. All right, so, we need to send this, it's up in the numerator, so we need to send it down to the denominator. Don't forget, those parentheses are still there, but now it's a positive 2. Okay, up in the numerator, nothing's left, so we need to show that there's a 1 up there. Okay, on this problem, we can go one more step, right? So let's go ahead and square that negative 8. Negative 8 times negative 8 gives me a positive 64. Okay, and I just want to point out again, if we did not put the parentheses around this, and say you typed just negative 8 to the power of 2 in your calculator, if you want to give it a try real quick, you're not going to get 64. You're going to get negative 64. Okay, so that's why the parentheses were important. Okay, down on the bottom, we have 1 over 2 to the power of negative 3. Cannot have that negative 3, so to turn it positive, this thing's down in the denominator. We're going to send it up to the numerator, and now it is a positive 3. Okay, on the bottom, there's just a 1 left over, but let's go one more step. Let's actually cube this 2. So 2 times 2 is 4, times 2 is 8. All right, last one, D, we have this negative 2 that needs to be applied to everything in here. Before we worry about changing it to a positive, we need to apply it. So this 1 is given a power of 2, and this 3 is given a power of 2. Okay, now we can get rid of those negative exponents. Let's start with the top here. I'm going to send this 1 to the power of negative 2 to the bottom, and now it is a positive 2. Send this 3 to the power of negative 2 to the top, and now it is a positive 2. Okay, and let's see, 3 squared is 9, so I'm getting 9 over 1. Going one more step, 9 over 1 is just 9. All right, so yeah, those are the new rules. Hope you're feeling good on those. We still have some more to look at. Real quick here, this isn't anything new. I just kind of want to remind you real quick of this is the stuff that we've learned so far, where we add our exponents if we have the same base being multiplied, power of a power, multiply, power of a product, apply to everything inside. Quotient powers, this says subtraction, but again, I want you guys to think of it as canceling. Okay, and then same thing here, power of a quotient gets applied to all of everything, the top and the bottom. So that's just a quick little review because we're going to be using these rules on the following problems as well as our new rules. Okay, so everything's kind of getting piled on from here on out. Okay, so real quick, we're going to do these two together. Go ahead and copy them and we'll try them out. Okay, so taking a look at number one, this problem is actually kind of interesting. There's multiple ways we can do this problem. Okay, here's one way of doing it. We can realize, oh, 6 times 6, that's the same base. This is using the very first rule we ever learned. If we have these, we can go ahead and combine or add together our exponents. Okay, and a -4 -4 plus a 4 gives us 0. Okay, so this is actually giving us 6 to the power of 0. Well, what is anything to the power of 0? It's 1. Okay, and there's our answer on this one. All right, here's another way we could have done this problem. We could have realized that this 6 to the power of -4, we could have gotten rid of the negative and sent it down to the denominator. All right, so if you could imagine, this 6 to the power of 4 would be up top. This 6 to the power of -4 would be sent to the denominator, and it would now be a +4. Okay, well, what do we have here? We have 4 6s up top, and we have 4 6s on the bottom. If we were to cancel all of those out, we'd be left with nothing. Okay, and remember, when we have nothing, that would be a 1 on the top and the 1 on the bottom, which again would give us just 1. Okay, so my point on this problem is there's multiple ways of getting to your answer on these. Do whatever looks easiest or quickest to you. Okay, on this one, I'm thinking, this top one was probably the fastest, easiest way, but the bottom one wasn't much more work. Okay, so if you want to separate these by like a line or something, just to kind of show there are two different ways of doing the problem, or if you just want to erase one and leave the one you like, whatever works for you. Okay, take a look at number 2. We have this power of 2 on the outside. It needs to be applied to the inside of the parentheses. So this is really just the power of a power rule. So we're going to multiply these. So we're going to get 4 to the power of -4. Okay, but we can't have negative exponents. So let's go one more step and let's send this 4 to the power of -4 down to the denominator. And now it is a +4. Okay, up in the numerator, show that nothing's left up there. Okay, and to the power of 4, I don't need you to do that math unless it explicitly asks for it. So we'll just leave it as is. Okay, so yeah, I'm gonna have you guys try a couple of these on your own real quick. Oh, actually, no, this is another example. We're gonna do a couple more together. Okay, so real quick, go ahead and just this can be an extension of the last example. Go ahead and get these number 3 and 4. Okay, so number 3 is seemingly simple, but very easy to mess up. We have a negative exponent. We need to get rid of it. Okay, here's what you might be tempted to do. You might be tempted to go, oh, I'm going to send this 2y to the power of 3 down to the denominator, and I'm going to be done. No, okay, this is not correct. The only thing that has a negative exponent is this y. Technically, this 2 has a power of +1, an invisible 1 if you want to put that in your notes. Okay, so this 2 that's up in the numerator is not moving. The only thing that needs to move is this y to the power of -3, and now it's a +3. Okay, and then double checking if I can cancel anything out. No. Okay, taking a look at number 4, this is kind of the same idea. The first thing I notice is this y to the power of 2, it's not moving. It's in the denominator. It does not have a negative exponent. It's staying down here. Okay, but this x to the power of -5, yeah, it needs to move to be able to turn positive. So it's going to move down to the denominator. And by the way, when we write our variables, we normally write them in alphabetical order. So we would probably write the x first and then the y. Okay, so it looks a little funny. Okay, but up top, there's nothing left over. So we got a 1. Okay, so the big thing, just kind of look out. It's really easy to move more than you need to when you're dealing with negative exponents. All right, so I'm gonna have you guys go ahead and try out these problems on your own, and then we'll get close to the end. All right, so on number one here, first thing to realize, this x squared, it is not moving. It is staying up in the numerator. Okay, but this y to the power of -3, to turn it positive, it needs to move down to the denominator. Now it's positive. Okay, I'm noticing nothing to reduce. We're good. Okay, on number two, be careful on this problem. We do have negative exponents. Those will be moving, but is everything moving? Okay, no, this 5 to the power of 1, it is not moving. It's up in the numerator. It's going to stay up in the numerator. I'm going to put my work down here. So this 5 is staying up top. What's moving is this m to the power of -3. Now it's a positive. And this n to the power of -4. Now it's positive. So there it is. Okay, so yeah, that is that for our lesson, guys. So nothing too crazy with the negatives. But yeah, if you have any questions, let me know. I'll see you. Bye.